Okay, so let's pay. So listen up, huh? So Peter had twice as much money as Amber at first. Peter spent 1/3 of his money and Amber spent 2/3 of her money. In the end, Peter had $75 more than Amber. How much money did Peter have at first? So a recap on what kind of question is this. So when you read a question like this, you will notice this question involve transfer. Transfer means you spend the money or you buy something. So there's two types of problem sums. One is actually there's three types of problem sums. Broadly, the first type is when you're primary one, where you call parts and whole. So it's one bar and then you split into parts, right? So this one type. Second type is comparison model, where you compare things. So if John has 30, Peter has 40, then find a difference, or John is seven more than Peter. So it's comparing. Those are the second type of problem sum. The third type of problem sums involve transfer. Transfer is like John give 30 to Peter, or John spent $40 and as a result, he is left with half of his money. So it involves transfer. Whether you are transfer between each other, you are transfer out of the group. As for transfer kind of question, there's two types. The first type you'll learn all the time. You transfer like $50, $30, pay 50, use 30, use 10 grams. So the transfer is a value, a whole number. Now, this is the type that is difficult, where the transfer is a proportion. A proportion means it is not a whole number. In primary 5 context, a proportion is most likely going to be a fraction. So instead of, in this question, you can see that Peter spent 1/3 of his money. Normally, when you're in primary 4 or earlier, or primary 5, the transfer is Peter spent $4, Peter spent $3. That's the normal way the questions are being set. However, when you read a question like this, you can see that instead of $3, $4 or $5, whatever that Peter spent, it tells you Peter spent a proportion of his money, and that's 1/3 of his money. Correct. So when you read a question like this, why do you need to know what kind of question they are setting? Because once you know the question, this is the way the question is set, then the way you approach will be different. Okay. So when the question is a proportion transfer, like in this case, then the way you record has to be different. Okay, so this is some recap. Now let's start. When you do recording, you always start with sentence by sentence. Don't do everything one shot. Sentence by sentence, literally sentence by sentence. Don't do everything one shot. So first sentence is Peter had twice as much money as Amber. Okay, the way you record this, you can draw Peter as 2 units and Amber as 1 unit, as 2 box and 1 box. But this is a bit easy. This is what you do in primary 4. But in primary 5, since you have learned ratio, you can record like this. Peter has twice as much as Amber. So Peter is 2, Amber is 1. Next. So the first question, I'm going to go a bit slow. Subsequent question will be faster. So Peter spent 1/3. So this is a proportion transfer. The way you record is this: Peter minus 1/3. Okay, so this is just for the purpose of recording how much Peter spent, but it's pretty useless until you translate this into whole numbers. So when Peter spent 1/3, it means that Peter must have 3 parts. All right, if he spent 1/3, if Peter is able to spend 1/3, meaning Peter's money must consist of 3 parts. Before, he must have 3 parts. He spent 1/3, means he spent 1/3, 1 part, and he's left with 2 parts. Okay? Now, let's continue. Amber spent 2/3. Okay, draw a line to do the Amber spent 2/3, meaning Amber must have 3 parts and she spent 2 parts of the 3 parts. So 3, begin with 3. She spent 2 parts and left with 1. Let's continue. Sentence by sentence. In the end, that means this is before, these are the change, then this is after. Peter had 75 more than Amber. So how do you record this? Whenever you see more than, you must record as a model. Okay, this is a rule. Remember, there's no other way to record other than model. more than, less than, always record as a model. So Peter has $75 more than Amber. So this is a very simple model, right? Now, you have recorded everything. The matrix method is this. Step 1, you record. Step 2, you look for common base. So common base, to look for common base, compare the ratios. So there's 3 ratios here. So the common base is the before of Peter and the before Amber must be the same. So this is the before of Peter. This is the beginning of Peter. So these 2 numbers must be of the same value. Similarly, this is the before of Amber. This is the beginning of Amber. These 2 numbers must be of the same value. So let's make them the same. Okay. Okay, this is so the before Peter and before Amber. So make them the same. Make this to 6 times 3. Over here I times 2. I'll make this to 6. You see? 6 and 6, right? Now let's look at this. Amber 3 and this is okay. Nothing need to be done further because they are already the same. So we got 2 common base. This is the first one and this is the second one. Once there's common base, that means there's no need to use units and parts. Everything's the same. Every unit is the same. Okay. Once you got common base, ignore what was before. 3, 1, 2, completely ignore. Just focus on this. 6 and 3. Ignore 2 and 1. Okay. Now, step 1, record data. Step 2, look for common base. Step 3, look for value in the question. The value in the question, if you record carefully, properly, the only value in the question you can see is $75. There's nothing else. Right? Now, $75, once you identify what value it is, you must ask yourself, how many units does this $75 represent? Right? So this $75 is basically the difference between Peter and Amber in the end. Right? So Peter in the end is, look here, 4 units. Amber in the end, 1 unit. So this is 4 units and this is 1 unit. Therefore, $75 is 3 units. Then you find 1 unit, which is the step 4 of the matrix method. Last step, read the question again. How much money did Peter have at first? This is very easy. Just pick the right number. Peter at first is this or this, whichever is fine. They are the same number. Don't pick 4 or 2. Please pick. And the common mistake people made is they pick 2. They pick this number. So 2 times 25, wrong. Or they somehow go pick 3 times 25, also wrong. Use the numbers that you have achieved, you have done common based. Okay, so it's 6 times 25. Answer is 150. All right. If you use 75 times 2, so what's 75 times 2? 6. Okay, yeah, you can do that also. You can do that also, Baden. Okay, someone use 75 times 2, you can, because 3 units is 75. Then if your working has 6 units, then you're okay. Answer is 150. Okay, everybody, let's go on to question number 2. Let's listen. I'm going a little bit faster. Again, the process is the same. It's not just for this question, it's for all problem sums. You must always use the 5 steps. Record data, look for common base, then make the common base the same, then look for value. Ask yourself that value is equivalent to how many units. Step 4, find the value of 1 unit. Step 5, read the question again. There's always these 5 steps. Please remember this. Where do you see these 5 steps? I don't know. You look at the it's in one of your worksheet. I think in lesson number 20. It's like the second or third lesson of a ratio question, your worksheet. Maybe lesson 25 or 26. We have been doing these 5 steps all the time. Okay, so focus. You can refer to your lesson 25 or 26. I'm not exactly sure, but it's the early part of your ratio lessons. Okay, let's start with sentence by sentence. Box A is had thrice as many species as box B. So A to B is 3:1. Next, 2/9 of the species from A were removed. So this is a proportion transfer. you're transferring out 2, 9, which is a proportion from A. So A minus 2, 9. And then to record this, translate this into a whole number. That will be 9 parts, taking away 2, leaving 7. Okay, so 2, 9 means you take out 2 parts out of a 9 and you're left with 7. Now for B, you took out 1/3. So 1/3 means you started with 3, you take out 1, so you are left with 2. In the end, there were 1, 2, 5 fewer squishy in box B than box A. So it's 1, 2, 5 fewer than. You draw a model. So this is how you record this. B is 1, 2, 5 fewer than A. Be very careful. Don't swap wrongly. Write A, don't write B on top, A below. Be careful. Now, that is step 1. Step 2, look for common base. Always look for common base. I'm warning you because a lot of students just forgot to do common base. And you don't do common base, you probably still can get sound logical answer, but end up you'll get wrong because the units are not of the same value. Okay, let's do. So the beginning of A, so the common base is the beginning of A, box A, and the before of box B. So beginning of A and box and B must be the same. So this number and this number has to be the same. This number 1 and this number 3 has to be of the same value. Okay, let's make them the same. So let's make the beginning of A the same, before. Make it to 9. Now you can see B is 3. Aha, this is 3. Good, they are the same. Nothing further need to be done. So we got a common base for A and common base for the beginning of B. Done. Now once the common base is done, you can ignore the old ratios. Okay, just use the new ratio, which is 9:3. 9, 2, 7, 3, 1, 2. Okay. Step 3, look for value. 1, 2, 5 is the value. And that is the difference between A in the end and B in the end. A in the end is this number, 7 units. B in the end is this number, 2 units. So, okay, the difference is 5 units. So 1, 2, 5 is 5 units. Any question until here? All okay? Am I going too fast? You have to write in the chat if you are not following. Okay, good. Let's continue. 1 unit is equal to 25. Now, always remember to read the question again after you got the value of 1 unit. How many squishies were in both boxes at first? So they're talking about A and B at first, which is what? Which is this at first, 9 plus 3. So it's 12. So 12 times 25, and that's the answer. Okay? Good. Now, question number 3, everybody. Okay. If you find solving this question easy, then it's a really good thing, because this question I consider very difficult question, and you are able to solve it with the method that I teach you, and then you find it easy to do the flow, then that's really good, So if this kind of question ever comes out, it's like 4 or 5 marks question. So this method is actually simplify a very complex question into very simple steps. Yanni Amber had a total of 88 markers. After Yanni used half of her markers and Amber used 2/5 of her markers, they had the same number of markers left. So pretty easy. So Yanni Amber had a total of 88. This is how you record. Yanni plus Amber 88. You can do anything. You can do Y plus A, then make it a title and write 88. Doesn't matter, okay? Your recording has no bearing on marks. So however you record, nobody will give any marks. No? The marks are, okay, for example, let's go back to just now the question. So this has no marks. Okay, this has no marks. Marks will be given to this portion only. Okay, so what then your question is, if all this has no marks, why do I draw for? Why do I draw all these things, all record this for what? You need to record all these so that it helps you to understand the question, and your thought process will be more systematic. And if the teacher need to understand what you are doing, the teacher can refer to what you write here, and then have some idea that, okay, you are not doing this by fluke, you got a process to do it. Okay. So yeah, although there's no marks, it's still necessary to record the data. Okay, Yenny Amber, so record this. Yenny plus Amber is 88. Now Yenny used half, so that's pretty easy. 2 minus 1 left 1. Amber used 2/5. Okay, now you should be pretty familiar with this process. So 5 take away 2 left 3. They are the same number of markers. So same means 1:1. You can put 2:2, it doesn't matter, as long as numbers are the same. Now, step 1 done. Step 2, look for common base. Common base is that Yenny and Amber in the end got to be the same, right? Now, look at here. This is 1. This is 3. They're not the same. At the end, they have to be the same. So, I made them to 3. Okay? Now they are the same. Okay? Common base done. Now, look for a value in the question, which is 88. 88 is the beginning, meaning Yenny at first plus Amber at first must be 88. Yenny at first is 6 units. Amber at first is 5 units. So altogether, 11 units is equal to 88. 1 unit is equal to 8. Once you got 1 unit, again read the question. Oh, shit. Okay, how many markers did Amber have at first? Amber at first is 5 units, so 5 times 8. 40. Okay? Now let's look at question number 4. If you don't get the answer, then there is something wrong in the 5 steps, right? If you follow 5 steps strictly, you will know where you get this wrong. So let's start. There were 60 apples and lemons, meaning apples plus lemon is 60. Okay. After selling 1/3 apples means you take out 1/3 of apples. Apples start with 3, take away 1 left 2. 2/3 of the lemons. So take out 2/3 of lemons. Lemons start with 3, take away 2 left 1. The fruit store has 6 times as many apples left as lemons. So in the end, apples is 6 units, lemons is 1 unit. Okay, those who got this wrong, did you do this? Okay, I presume you did. This is the easiest. Okay, what I'm guessing is you didn't do common base. So the common base is that the n of apples, 2 and 6 has to be the same value. Lemon, 1 and 1 has to be of the same value. Okay, apples after and lemons after. So let's make them the same. Let's make apple the same. Make it to 6 times 3 across. Okay, lemons is already correct. So nothing further need to be done for the lemons. So I've got a common base. Step 2 done. Step 3, look for a value, which is this 60. And that is the beginning. So we are talking about the beginning of apples, 9 units plus the beginning of lemons, 3 units together gives you 60. So 9 plus 3 units gives you 60. So 12 units is 60, 1 unit is 5. Okay, those who got wrong, do you know what? Do you get 5? 1 unit is 5? Did you get 1 unit 5? Okay, if you get wrong, you must understand why you got wrong, right? I hope. Okay, now read the question. Last step, how many apples were sold? Okay, how many apples sold? Pick the right number. Apples sold is this. It's not, this is apples in the end. Apples at first. So 3 units is the apple sold. So 3 times 5. That's the answer. Okay. Now let's look at question number 5. Question number 5 is mechanical. It's mechanical. It's a long division. So remember, if you recall when you are in primary 3, I think you learn long division. Initially, you find it very difficult because you got to carry forward and stuff like that, minus, then bring up, stuff like that, right? It's actually not difficult. No. It seems difficult because there's a lot of mechanical steps that you need to follow. This is the same for question 5 and question 6. It's a lot of mechanical steps. But once you know the mechanical steps, question like this is very easy to solve. Just a long division. Okay? So if you find this difficult, don't worry. Just do a few more questions, you'll be okay. The only way to master the units and parts question is to practice. Because the reasoning behind is not difficult. It's just the mechanics that is tedious. So if you don't get it right, don't worry. Just have to practice. Okay, question 5. Question 5, the question is how many red marbles? So Amber had 35 marbles, and they are either red or green. So just record red plus green 35. Sentence by sentence. So the next sentence is she gave 2/5 of a green marbles and 1/4 of a red marbles away. So this is a proportion transfer. The green take away 2/5, so 5, take away 2, left 3. Red give away 1/4, means start with 4, take away 1, left 3. In the end, she had 24 marbles in the end, meaning in the end, green plus red is 24. You see, in a question like this, so step 2 is look for common base. There's no common base, obviously, because this is green and this is red. Nothing common between the green and red, right? And then they didn't tell you anything that link the green and red. So there's no common base. It's not like they tell you the green and red in the end is the same or something, right? Doesn't. So there's no common base. If there's no common base, the rule is units and parts. So let green be units and red be parts. Until here, everyone okay? Well, I'll go through slowly with this. Slowly with you with this. So are you okay until now? Everybody. So this is not a difficult question, believe me. So now, step 2 done, no common base, so units and parts. Step 3, look for value. Now, there's 2 values, 1 value here and 1 value here. So start with the first one. So this 35 is the beginning of green and the beginning of red. The beginning of green consists of 5U and beginning of red is 4 parts. So 35 consists of 5U green, 4 parts red. Okay? So record this way. Okay? Now, look at the next value. So there's 2 values in the question. The other value is 24. But this 24 is in the end. So we are talking about green in the end, plus, or 3 units of green in the end, plus 3 parts of red in the end, gives you 24. Right? Now you got 2 statements. Okay. Default. I always make units the same. Unless something really odd. Like if you make units the same, the value is so big. But by normally, I would say most of the time, you make units the same, it'll work. Okay? I know some people will say, oh, how many red? You're asking for red. So I should make units the same. If you're asking for green, I should make parts the same. I know. But just for consistency, don't think too much. Just make everything units the same. Okay? You want to do the other way around. If they look for red, then make green the same. Look for green, then make red the same. Also fine. It's fine. But for consistency and for easier, because there's many steps, and I just worry you all cannot follow all the steps. So you just maybe you just stick to make units the same. Okay? So make units the same. So times 3 times 5 times 3, make this to 15, right? So this statement so I make units here, I need to make this to 15. I need this to 15 also, make this to 15. So to make this to 15, I times 3 across. Then to make this statement 3 units to 15, I must times 5 across, right? I will get what? 3 times 5, 3 times 4, 3 times 35. And this is what I get. 3 times 5, 3 times 4 is 12, 3 times 35, 105, right? Now I'm going to do this for the second statement. 5 times 3 units, 5 times 3 parts, 5 times 24, and I'll get this. Okay? Now I'm going to minus I use the larger number here, 120 minus the smaller number. And to do that, on the right, I must do same for the left. 15 parts, take away 12 parts. 15 units, take away 15 units. Okay? So on the left, the 15 units will be gone. 15 parts minus 12 parts, you're still there. You get 3 parts. On the right, you get 120 minus 105. You get that will be equal to 3 parts, right? Got it? If I use on left side, I use this, subtract this. This will be equal to 120 minus 105. So 1 part will be 3 parts will be equal to 15. 1 part will be equal to, oh no, don't need to do that. So 1 part will be equal to how much? 5. Okay. Now question is, how many red marbles did she have at first? So we are talking about this. Okay, we are talking about this. At first, 4 parts. Red. Pick the right number. So this will be 4 times 5, 20. Any question? Any question? Okay, any more? Any other people got questions? Please, do you need me to repeat anything? Because this is very mechanical, and then if you need explanation, I'll explain to you. Okay. Okay, let's look at question number 6. Okay, let's record the data first. So John and Peter had $82 altogether. Okay. John spent 1/3. John spent 1/5, so 5 take away 1 left 4. Peter spends 1/4, so 4 take away 1 left 3. The total is $64 in the end. Again, there's no common base, so units and parts. So I'm going to form the first statement. The first statement is, third step is look for value, which is 82 and 64. I shall form the first statement using 82. 82 is the beginning of John plus the beginning of Peter. So 5 units plus 4 parts is 82. Now look at the second value, which is 64. 64 is the end of John plus the end of Peter. So 64 is equal to 4U plus 3 parts. Now, remember I tell you, you always make, okay, not say always. I recommend that you make the at first the same. Your home for a moment, someone is looking for me. I shall pause the recording. So earlier I was telling you, I recommend you all to always make units the same, right? Okay. In this solution, the teacher will do the solution, did the parts the same. And I know why. Because the question says, how much money did John have at first? So they're asking for John. So you make Peter the same. And Peter is parts. That's why they make parts the same. Right? It's just like your if you recall when you are doing supposition method, right? If they have cows and ducks, if they're asking for ducks, you make cows. You assume all are cows. If you're asking for cows, you assume all are ducks. Same idea, right? So I am fine with that. It's up to you. If you want to make units the same or parts the same, it's up to you. You want to use the solution method where if they ask for John, you make Peter the same. Ask for Peter, you make John the same. That is fine as well. Okay. Okay. So because the solution is already done this way, I am going to do based on making Peter the same. And do you know why you have to make Peter the same? Because why the solution recommended to do Peter the same? Because the question to be for John. All right. So when you make Peter the same, you remove the parts later. Okay. So look here. So I make parts the same. So Lisa, I will show you question 5 later. So let's make parts the same. Focus on question 6 now, Lisa. So let's make it to 12. Okay. So to make it this to the first statement P to 12, you need to multiply by 3. And then you have to multiply by 3 across. For the second statement, you need to make 3P to 12, you need to multiply by 4. And need to multiply 4 across. Okay, so the first statement multiplied by 3 will be 5 times 3, 4 times 3, 82 times 3, and you'll get this. Second statement, you multiply by 4, 4 times 4, 3 times 4, 64 times 4, and you'll get this. Okay, now use the larger number here on the right minus the small number. So 256 minus 246, meaning the second statement minus the first statement. Okay, and on the left side, your 12 parts minus 12 parts will be gone. The units will be 16 units minus 15 units. So on the left side, you get 16 units minus 15 units, you get 1 unit. On the right side is 256 minus 246. Therefore, 1 unit has to be equal to 256 minus 246. And you get this. Any question until here? Any question? Need me to repeat anything? Matthew, can you hear me? Matthew, can you hear me? Okay, because you wrote in the chat that you cannot hear me. If you can hear me, if you cannot hear me, please indicate again. So 1 unit is 10. Now read the question. How much money did John have at first? So we are talking about this. At first is 5 units. So 5 times 10. Okay? And that's the answer.